Welcome to Ask and Learn.
All right, the first part of this problem, this whole problem relies on looking at problem 83. And so the first part is exactly the same as problem 83. You're equating energy, you're doing energy conservation. So initially, at A, the skier has just gravitational potential energy, so mg times the height at A is equal to kinetic energy at B, 1/2 m VB squared. And so, you have very simply that VB is equal to square root of 2 times g times height at A. So this is 2 times 9.8 meters per second squared times 45 minus 4.4 meters. And so this gives us 28.2 meters per second for VB. Okay. All right, in part B, this is where we start diverging from the simpler situation problem 83, because you have different components. You have a horizontal and vertical component of motion, of B's motion, of motion at B. So from the Pythagorean theorem, we know that VB squared is the sum of the horizontal component squared and the vertical component squared. Therefore, the horizontal component, VBX, is just square root of VB squared minus VBY squared. So this is square root of 28.2 squared minus VBY is said to be 3 meters per second. Square that, and you get 28.05 meters per second as the x component of velocity at B. So x is just this x component of velocity times time. That's the horizontal distance traveled. Therefore, we have an expression of time, which is x over VBX. Next, we note that we have to find x. We really and we know y. So we really have to find x to find s, given a 30-degree slope. So y is actually x, or y over x is tan 30. So y has to be x tan 30, x tan 30. I should write 30 and not theta there, sorry. And so this will be a negative because y is going down. So y is negative x tan 30. Then we use our equation of motion, y equals y naught plus v by t minus 1/2 g times t squared. So plugging in everything from above, we have negative x tan 30 is equal to y naught, which is 2, it's 4.4, plus VBY is 20, VBY, I should say actually, let's not plug in everything quite yet. So negative x tan 30 is y naught plus VBY times t above, so x over VBX, minus 1/2 g times x over VBX quantity squared. Therefore, we have that gx squared. You work out this entire mess of an algebraic expression, you get gx squared minus x times 2 VBX times VBX tan 30 minus VBY minus 2 y naught VBX quantity squared equals 0. Now plugging in values, you have 9.8 meters per second squared x squared minus x times 2 times 28.05 as we found, times 28.05 tan 30 minus 3 minus 2 times 4.4 for y naught times 28.05 squared is equal to 0. All right. This is a quadratic equation. You can plug into your calculator to solve. This comes out to be have two solutions. X is negative 6.09 meters, and x is 116.0 meters. We're going to choose the positive value, obviously. So x is 116 meters. Finally, therefore, from this triangle, we have that s over x, or x over s, I should say. X over s is cosine 30. Therefore, s is x over cosine 30, or 116 meters over cosine 30, giving us 134 meters as the distance. And that's it.